Greetings, hello, welcome back. So, I've been thinking, we started solving this problem, but we did not solve it all the way to the end. So, my plan for this video is for us to go all the way until the end. So, we'll continue off with where we left off. We'll get all our properties and then solve this problem. We got our properties at state 8, state 9, and now we'll proceed to state 10, state 11, 1, 2, 3, 4, 5, 6, 7. All right, we'll go in that order and see where this problem takes us. So let's get started, shall we? All right, step 10. What do we know about step 10? From the TS diagram, okay, TS diagram tells us that we are in the superheated region, but we are not so sure about that. Let's confirm. We know our pressure is 0.7, 0.7, and we do know our entropy is the same as the entropy at state 9. So we'll use those properties to confirm where we are. So 0.7 megapascal and S9 is equals to S10. What was S9? That was 6.9045 kilojoules per kilogram Kelvin. Okay. So, what is this? Are we in the superheated region? Are we in the saturated region? Or are we in the compressed region? We don't know. The best thing to do is to check our properties against the saturated liquid table. That should tell us where we are. Okay, we're looking at 0.7 megapascal, 0.7, 700 kPa. Okay, 0.7 megapascal force in that range. Now the question is, are we in the superheated region or are we in the saturated liquid region, or is it a mixture region? Is it superheated or is it not superheated? That's what we want to find out. To do that, we'll check our entropy values, table A5. At 700. Okay. something did happen, of course. Okay. Let's try that again. All right. Okay, cool. Yeah, sorry about that. Yes, so this is table A5, saturated liquid table. So at the pressure of 700 kPa, which is the same thing as 0.7 megapascal, we are looking at this entropy, the pressure we found the pressure, that is the pressure. There's nothing wrong with the pressure. Now we just want to look at our entropy. What about our entropy? Is it the same? Does it fall within the range? So these are entropy values. Okay. Just draw this to help us visualize this. And 700 kPa, drawing that pressure of 700 kPa line, it looks like this. So this will be 0.7 megapascal, which is the same thing as 700 kPa. So the line looks like this on a TS diagram. Okay. So now the question is, in which region are we? All right. So at that point, I know that's my SG. Okay. And at this point, I know that's my SF. So what's my SF? My SF is 1.99, 1.9918. And my SG is 6.7071. Alright, so I need to compare this SG with my value that I have there. If my value is greater than the SG value there, then it means I'm in the superheated region. So I'm working with steam. However, if it is less, then it means if it is less and it's greater than SG, then it means it falls in the saturated mixture region. Therefore, I need quality. Okay. Looking at our entropy in this case, it is greater. What does that say? We're in the superheated region. You guessed it right. So this is the little thing that you should always be able to do mentally. If you can't do it mentally, just draw it like this. It helps out. It helps to reason. All right. Cool. So we're in the superheated region, so this we don't need anymore because we've decided we're in the superheated region. So superheated region it is. Nope, saturated liquid, superheated region. There we go. Table A6. We are looking at 0.7 megapascal, and this tells me double interpolation is of necessity here. So you will need to do double interpolation, which I've already covered in the previous video. So to get you started with that, this is what you would do. You would say, okay, I have a pressure of 0.6 as my lower limit, 6, and I'm looking for 0.7, and my higher limit is 0.8. Okay, my entropy is 0.69045. 6.9045. First I interpolate using entropy, and then later interpolate using pressures. 6.9045. 6.9045. 0.8, it falls in there, so 6.8, 177, 7.0402, and enthalpy is 2950.4, 2839.8. Okay, we do the same here at 0.6. Where does 6.9045 fall? 6.904. 6.904 is in that region. So 6.7593, 6.96 at 3, 2756.2. 28 is my lower limit, 50, just taking down the value of 0.6. And then we can call this HA, call that HB, and then can go ahead and get the values, what you get for HA, what you get for HB, place it there, and then after that, finally, you would interpolate between the pressures and your newly found values. Then you're done. And if you do that, I'm not going to do it because I've already made a video on how to do that. Just get that video. So H10, if you do your double interpolation, you'll find H10 to be equal to 2852.37. So that will be H10. Okay. So the value for H10 will be 2852.37 kilojoules per kilogram Kelvin. What? No Kelvin, just kilojoules per kilogram. Okay. Yeah. Alright, cool. So now we move to state. Where are we? Okay, state 10 we're done. Now we move to state 11. Okay. State 11. What do we know about state 11? We know that the pressure is 11 kPa. We know that entropy is the same thing as entropy at 10, which is 6.9045 kilojoules per kilogram Kelvin. Question is, in which region are we? Are we in the superheated region, saturated mixed region, or compressed region? To answer that question, we need to look at the properties at the constant pressure of 11 kPa, look at SG and SF, see where our given S value falls, and that should give us an idea of whether we need quality or not. So to do that, we'll go to a pressure of 11 kPa, and if I'm to go to table A5, because we're given a pressure, table A5 tells me that 11 falls in there. Now, I have no idea what my values are. So to get those values, I need to interpolate. Yeah, I need to interpolate. And interpolation will allow me to see if SF is greater than or less than my given entropy. When I say SF, I mean entropy at the saturated liquid state. Okay, so I'm interpolating between 10 and 15. Okay, that's cool. So we have 10. I'm interested in 11, 15. Interpolating. This is pressure in kPa. I'm going to interpolate between HF, HFG, SF, SFG, and SG. Okay, H10, that's 191.81, HFG 2392.1, 0.6492, 7.4996, 8.14148. Looking at SG, adjust the value of SG from 8.14, that is 15 at 10 kPa, and then at 15 kPa it decreases to 8.0071. That tells me that this value of SG is greater than my given entropy value. Therefore, I will need quality to work out my properties at state 11. There's definitely need for quality here. 7.2522. Luckily, I can find quality because I have S11. This is 0.7549. HFG, that is 2372.3, and then we have 225.94. Okay, this is just straight away linear interpolation, which I'm assuming we are all able to do. But if you can't do that, all right, I'll do a few for us, just so that we can get in the habit of doing it on our own. I'll interpolate between that range. Okay, I'll interpolate for SFG. Okay, I'm interested in 11. So 11 minus 10 divided by upper limit minus lower limit should be equal to SFG 11, what I want, minus 7.4, that minus that, divided by that one minus that one. 7.2522 minus 7.4996. SFG is equal to this, gives me 0.2. 11 minus 10 divided by 15 minus 10, that is, yeah, that should be 0.2. Multiplied by 7.2522 minus 7.4996 plus 7.4996. All I'm doing here is just making SFG 11 subject of the formula, and then finding out that FG11 is equal to 7.45012 kilojoules per kilogram Kelvin. Okay, and then you do the same for SF. Yeah, do the same for SF. In that case, SF, remember, we are looking for quality now. So the formula for finding quality at state 11 will be equal to S F at state 11 plus X multiplied by S FG at state 11. So we do need SF at state 11. So SF at 11 is equal to 0.2 multiplied by 0.7549 minus 0.6492 plus 0.6492. Right, just 0.2, right, 0.7549 minus 0.6492 plus 0.6492. Okay, that gives me 0.6703 kilojoules per kilogram Kelvin. Just confirm this on your side also. Okay. Cool. So now we can find quality. Need to get HFG. how we can find quality. But before we go ahead and find quality, we need to get HFG11. We do the same procedure, 0.2 multiplied by the difference. Okay, just the same procedure. HFG will be, what will be HFG? 2388.14. If you do that whole process, it will give you that, and HF11 will give you 0.2 multiplied by the difference, 225.94 minus 191.81 plus 191.81. That should give us 198.64. So what I'm doing here is the manual approach at doing interpolation. There are guys that can use calculators. If you're comfortable with that, go ahead and do it. I'm comfortable doing it this way. Okay, cool. So that's HF11 and that's HFG11. I think now we're all set to find quality. From here, we can say that S11 minus SF11 is equals to X SFG11. Therefore, X, which is our quality, is equal to S11 minus SF11 divided by SFG11. That gives us, well, 6.9045 minus what is this? Okay, minus F11, SF11, 0.670334 divided by 7.45012 gives us quality of 6.9045 minus 0.67034 divided by 7.45012 gives us quality of 0.8368. Alright, therefore we can finally get our enthalpy at state 11, which is just HF11 plus X HFG11. We have this, we have quality, we have that, which are those right there. So 198.64 plus 0.837 multiplied by 2, 388.14. This by 2388.14 plus 98.64 gives me 2197.00. Alright. Okay, yeah. So this is the value for enthalpy that I'm getting. I'm looking at it, I was like, wait, this enthalpy value somehow doesn't make sense, but it actually does make sense. If you look at a TS diagram, what am I doing? Nope. Constant pressure. We have HF right there, and our quality is somewhere 0.8, somewhere there. So it does make sense. It's close to HG. It's closer to HG than it is to HF. So yeah, makes sense. Just confirm it on your side as well though, okay? Alright, cool. Plan for this video was for us to get done with all the stats. However, I guess this video just boils down to finding state 11. So that's how you find state 11. Keep learning. God bless you and keep you. Get ready for the exam and shine.